Welcome to David Alexander Maths Tuition. This is chapter 9F on the graphs of sine, cos and tan. So it's really important that you are familiar with what these graphs look like. So here is the graph of the sine of x. So here is our x-axis. So here y equals the sine of x. So the important thing is that the maximum point is 1 and the minimum is -1. So the sine of x is always between -1 and 1. And it repeats every 360 degrees. This is 360. So between 0 and 360 it goes up, then down, then up again. And for the next 360, which will take us up to 720, again we've got a hump going up, or a little hill there, and it's going down beneath the axis up to here, which will be 720. So we need to remember it repeats every 360 degrees. Got a maximum of 1 and a minimum of -1. So it's really important that you can just do a quick sketch of the sine of x between 0 and 360, and it starts at the origin, goes up, then down, then up again, and there we go. So that is 0 to 360 degrees, and just remember maximum of 1, minimum of -1, and that it continues to repeat to infinity. Now the graph of the cos of x, in many ways it's similar. It's got a maximum of 1 and it's got a minimum of -1. The key thing with cos, what makes it different from sine, is sine starts at the origin, whereas cos starts at 0, 1. Again, cos repeats every 360 degrees, so between 0 and 360, which is here, it goes down to the bottom and then comes back up again. So for the next 360 it does exactly the same thing, so it's all the way down to -1 and then comes all the way back up again. So this point here, so if this is 360, this is again double 360, so 720. So the key thing with cos, again, maximum of 1, minimum of -1, and it repeats every 360 degrees, like sine as well. The only key difference is it starts at 1, whereas sine starts at 0. So this is the graph of the tan of x. So the key thing to remember here is it goes through the origin. Now if you're doing a sketch of tan, so it's going to come up through the origin and up again. Now we have an asymptote at this point here and at this point here as well. Now this asymptote is at 90 degrees and this one is at -90 degrees. So tan repeats every 180 degrees. There's 180 degrees between -90 and 90. The curve will never touch -90 and it will never touch +90, and it goes through the origin, as I said before. So we can do another tan curve like so. So as it repeats 180 every 180, the asymptotes repeat every 180. So this next asymptote is 270 degrees. If it cuts through here at 0, if I add 180, 0 plus 180 is 180, so it's cutting through again at 180, and the next place where it will cut through will be at 180 plus 180, so 360, and the next asymptote will be at 270 plus 180, which is 450 degrees. So that is the graph of the tan of x. So key thing to remember, it cuts through the origin, has an asymptote at -90 and +90, and then the whole thing just repeats every 180 degrees. Okay, so here we're thinking about different solutions to problems here. So we know that the sine of 60 gives us √3/2, but there are other values which will give us √3/2. So if I just draw a graph of the sine of x, so we know that the maximum is 1 and the minimum is -1. So between 0 and 360, how many solutions are there that will give us √3/2? So √3/2 is, well, it's somewhere between 0 and 1. Let's just say it is here, √3/2. So we get √3/2 when we sine 60, but we also get √3/2 when we sine whatever this value here is. Now this value here is 180 minus 60. This distance here is 60 degrees, and it's exact due to the symmetry of the sine graph. This is also 60. So at this point here, because we're halfway through the wave, this is 360, so this is 180. then this is going to be 180 take away 60, so 120. So the sine of 60 will give us root 3 over 2, and also the sine of 120 will also give us root 3 over 2. Now, because sine repeats itself every 360 degrees, if I add 360 on to 60, 360 plus 60 is 420. The sine of 420 also gives me root 3 over 2. And if I add 360 onto the sine 120, that would be the sine of 480. That will also give me root 3 over 2. And again, just type it into your calculator and just test that out. So we need to remember that there are an infinite number of values that when I sine them, I'll get root 3 over 2. It just depends on what range we're looking at. If we're looking at just between 0 and 360, there are two values that will give us root 3 over 2. One of them is 60, and the other one is 180 take away 60, which is 120. Okay, so the cos of 45 is root 2 over 2. So again, let's find another value of x for which the cos of x is root 2 over 2. So here is my cos graph. Okay, so here we are at 360 degrees. Now we know that so this is 180, so this is 90, so 45 is here, and that is giving me root 2 over 2. Now so the cos of 45 gives me root 2 over 2, but also another value here gives me root 2 over 2. Now this is a distance of 45 degrees, and as this is 45 degrees as well. Again, it's just the symmetry of the cos graph. So this value here is 360 take away 45. 360 minus 45 is 315. So the cos of 315 will also give me root 2 over 2. Okay, so and again, if I've got the cos of 45 and the cos of 315 giving me root 2 over 2, since cos repeats itself every 360 degrees, then the cos of 360 plus 45, so the cos of 405, will also give me root 2 over 2, and also the cos of 315 plus 360, which is the cos of 675, that will also give me root 2 over 2. Okay, so here we know that the tan of negative 30 gives us minus root 3 over 3. What we need to know is that tan repeats itself every 180 degrees. So here is the tan of minus 30, and it's given me this value here of minus root 3 over 3. So we've got an asymptote here, which hopefully we know is 90 degrees, another asymptote here, which is minus 90. So if I chuck in another tan wave, so the next asymptote will be 270. Remember, tan repeats itself every 180 degrees, so minus 90 is the first asymptote, plus 180 is 90 for the second asymptote, plus 180 gives me 270 for the next asymptote. So what we've got here is we've got negative 30 giving us negative root 3 over 3, but we've also got this value here. So how many degrees is that? Well, it's going to be negative 30 plus 180, so that is 150 degrees. So the tan of 150 degrees will also give me minus root 3 over 3. Again, if I add, remember tan repeats every 180, so 150 plus 180 is 330, so the tan of 330 will also give me minus root 3 over 3. And again, if I add another 180 to that, I get 510. The tan of 510 is also negative root 3 over 3, and another 180, so the tan of 690, again, also negative root 3 over 3. So the key thing with tan's probably one of the easiest ones. It might be one of the hardest ones to draw. It might be fiddly because we've got the asymptotes, but remember, what does make it easy is the fact that it repeats every 180 degrees, whereas sine and cos repeat every 360.